So part B, they want you to rotate this area here. Okay, here. This vertical line. So there's a huge empty space between -1 to our area, right? So there's going to be, first of all, an empty space of cylinder. Like there's an empty space here. That's going to rotate too. So up to -2, there's nothing. And then up at -3, so from -2, there's going to be a line. Okay, and then the parabola. Okay, so I'm just gonna do my best to draw a circle. So there's a circular. I don't know if that helps things to be more 3D. Some computer generated shading. Okay. Okay, let's set it up. Again, the disk's radius r, right? It's a horizontal component. Okay, so the radius is going to be a function of y this time. Okay, so let's do volume. Okay, now from where to where do we integrate? Right, because the radius is this, we're still going to integrate up, right? So it's 0 to 1 still. We know that that's 1. Okay, the y value is 1. Okay, so this time I'm going to just put pi here. The radius, the bigger radius, so I'm going to call that 1 as a function of y, minus a smaller radius. Okay. You know, like the smaller radius, okay, in this one actually we need a formula for it, but the previous examples, you know, we had a cylinder, you know the formula for the cylinder too, right? So you could just use that formula as well. But in this one, it's not a cylinder. So, okay, so let's take the longer one. Let's take that to be R1. Okay, and the one inside, the shorter one to be R2. Okay, so that makes this point, right? This point right here, R1 y, and it makes this point right here R2 y again, right? Actually, that's incorrect. Why is that incorrect? I made a small error there. If this whole thing was R1, this coordinate will be, it has to be from the origin, right? It has to be from the origin. So it's actually going to be R1. We got to take this out to see this length from here to here. What is our length? That's 1, right? So it's actually R1 minus 1 y. Same thing. This length is 1, so it's R2 minus 1 y. So for the parabola, that means R1 minus 1. That's the x value. So y is equal to R1 minus 1 squared, isn't it? So then R1 minus 1 is going to go to square root of y. And R1 is not going to equal to square root of y, but square root of y plus 1. That's what happens when you rotate like that, about there. So let's find R2 as well. R2 minus 1. Right, so we're going to use the y is equal to x. X is R2 minus 1 y. So R2 is y plus 1. Okay, so we have our radiuses now. So we can plug that in, right? This one in here, and that one in there. So let me continue here on the left side. I'm running out of room. So the volume is then pi integration from 0 to 1. R1 was root of y plus 1 squared, and it's y plus 1 squared. Okay, so we get that. Clean that up, and we get The 1 cancels out, so we get and the y and the 2y will cancel to minus y plus 2 root y minus y squared. Alright, so we have pi and negative half y squared plus 2 times 2 over 3, so it's 4 over 3. I'm skipping some steps here, so if you need to do it slower, do it slower. Like that. Okay, so let's plug 1 in. You don't need to plug in 0, just 1. And we're going to get minus half plus 4 over 3 minus a third. These two will add up to 1. 1 minus half will give you exactly half. So it's pi over 2. Pi over 2 unit cubed.